Welcome to another Weather Band webinar. We are thrilled to have Mallory Brooke with us here today to talk about weather and the ski industry. Mrs. Brooke is one of the select few to hold both Certified Consulting Meteorologist and Certified Broadcast Meteorologist seals from the AMS. So we're really excited to have her expertise here and also to address this fascinating topic of forecasting for the ski industry. So I will ask that you put your questions in the Q&A box. Mallory will get to those at the end of the talk. We'll have some time for Q&A then. So again, hit that Q&A button at the bottom of your screen to submit your questions so we can keep those organized and make sure they get answered. I will be monitoring the chat box as well. But I think as long as you get those in the Q&A, we'll get them answered. And without further ado, I will hand it over to you, Mallory.
All right. Thank you so much for having me. And I'm excited to speak to everyone today. It's a topic that has only recently come into my purview once I started in consulting. And so it's really become my passion as I work with a lot of skiers, mostly around the Northeast, but we'll get into that in a little bit. So we'll go through a bit about me, a bit about my business and the overview, what we look into snowmaking forecasts, what forecasts do we look at, teleconnections, how do I put the forecast together? And then we're really going to hone in on how these forecasts are utilized in a really microclimate way, which I'm going to focus on the World Cup, which is the women's skiing in Killington, which began in 2016. It was the first World Cup event to be held in the East in over 40 years. So it was a really big deal to get this event at Killington, so much so they had a private meteorologist come on staff to be there to help run the event. And then we'll talk a little bit about the clientele and more about the specific ski areas that I'm working with. So a little about me. I'm a Penn State graduate. I graduated the meteorology program in 2008. I'm currently pursuing my MBA at the University of Maine and am expected to graduate in May. I will be walking in May 2022, hopefully in person. And I was initially in broadcasting. I left Penn State and drove myself to the Shenandoah Valley in Virginia for my first job. I was there for 3 years with the local ABC affiliate, and that's where I obtained my CBM seal in 2010. From there in 2011, I really loved snow. And so at that point, I decided to move north and pursue a job in Portland, Maine at the local ABC affiliate there. I spent about 7 years there before leaving broadcasting full time to open my own consultancy. This was kind of an alignment of stars and opportunities that came my way while I was still in broadcasting, the World Cup being one of those where I met a gentleman where I ended up buying his business from him when he was retiring. So his name was Tony Visano. He forecast for ski areas for about 40 years and took me under his wing in 2014 to learn the methodology and the ins and outs of forecasting for ski areas. And then in 2016, the Killington World Cup came about and he was too busy to be there on site. And so he sent me instead. And that's how I really got involved in forecasting slopeside. And in 2017, he said, this is going to be my last winter. And do you want to do this? So I eventually said, I do. I wanted to get out of broadcasting. I've been waking up at 1:30 in the morning for 10 years and I was done with it. So that's a little bit about the progression. So in 2017, I launched my business, which is Nor'easter Weather Consulting. I've run it by myself. I work with 2 developers who do all my web and development work. And I have a contractor who can fill in for me as needed. But I provide pinpoint customized forecasts to weather-dependent businesses, mostly ski areas. About 70% of my business is for ski areas. I also work with cross-country trail centers, utilities, plow contractors, and also with events and weddings, especially since I'm based here in Maine. It is a very big destination place for weddings in the summer, and they are typically outside. So we have special forecasts that go out for those folks. I also am really big into engaging students in STEM. I still work and mentor with some of my past professors at Penn State. And I also visited over 250 schools in my time, or 250 school visits. They may not have been different schools, but 250 separate school visits in my time in broadcasting through a Weather at Your School program, and did Weather at Your Classroom when COVID came down last spring, to add a little enrichment to the teaching at home deal that we had to do. I also still freelance in broadcasting at a different station with the local NBC affiliate here in Maine. And I fill in from now my house, which is great. And I also produce and write The Outside Edge, which is a series in both winter and summer to highlight outdoor recreation. And sometimes I'll even go live right from my driveway or my backyard during winter storms, since I am about an hour removed from Portland. So that's a little bit about the business end of things. But what it comes down to in the core is how to provide these pinpoint forecasts that are more valuable than an app and what you're going to get on a website. And so that's where the intel, the experience, the education has really set me up quite well coming out of Penn State and then continuing my education through my CBM seal. And I did get the CCM seal, the Certified Consulting Meteorologist seal, last October. Actually, it was almost a year ago today that I had my final oral interview for that. So as mentioned, one of the few that have both, and it's nice to have those two overlap a little bit, because I think they actually help each other quite a bit. So in the grand scheme of things, when I'm forecasting, and I'm going to hone in a bit more on ski areas because they like short-term and long-term, we're looking at weather patterns, we're looking at models. A lot of what we look at ends up being a little bit of long-term, mostly short-term. But of course, as I'm sure everyone gets asked, or most meteorologists get asked at this point in the year, what's the winter going to look like? So we try to avoid going too far into that. At least I do, because I'm definitely more of a short-range forecaster. But I definitely still utilize some of the forecasting methods to go out more than a week or two. And a lot of these are going to be teleconnections and oscillations. And so a lot of them we know, and some of them I particularly hone in on, especially in the wintertime. So we all know El Nino, La Nina. We're just into a very weekly neutral La Nina. I think we're right on the border last that we checked. And yeah, we were at 0.5 degrees below, or a standard deviation below. So we were staying in that very weak La Nina, this coming out from the Climate Prediction Center just a couple of days ago. So that is where we are right now. Obviously, with being in the Northeast, there's really no hard and true, it's La Nina, this is what's going to happen for the winter, but it's something we certainly take into account, especially when we're in a strong phase, strong El Nino, like we saw in 2015, or the Super Nino. It was not a good winter here. And we were expecting that because of the enhanced El Nino, and strong La Ninas are typically not good in the Northeast either. So when you're on the extremes, we typically don't do well winter-wise, and neutrals are definitely one way or the other. And weak La Ninas, weak El Ninos can actually go both ways as well. So it's not a terrible place to be going into winter, but it's something that we certainly look at along with our teleconnections. Now, some of these don't have a lot of credibility in the early season, because remember that we're still in a transitionary phase. So especially where we're looking at factors that have to do with sea surface temperatures or sea level pressures, we're obviously going to start to see more deeper gradients as we start to go into the winter time. So things like the AO, the NAO, they're not strong indicators in the early season, but they're really good indicators as we get into the latter part of the season. Watching the PNA right now is helpful. It's showing where we're getting those troughs and ridges throughout the US. And we also look at the EPO fairly consistently, a little bit more now as an early season indicator. Are we going to see some cold pushes coming into the Northeast. Most of my clientele is in the Northeast, so that's a big focus of mine. I'm just gradually moving westward. I have 2 resorts in Michigan, and I've had a lot of interest in the Midwest, as well as even getting out into the Rockies. So haven't quite gotten there yet, but I think it's only a matter of time. But most of the forecasting I do is for the Northeast. So we'll go through these pretty quick. I'm sure a lot of you already know quite a bit about the teleconnections that we look at, but we have the Arctic oscillation, where you're in the positive phase. It's not usually a good place for us to be in the winter, where the cold is really trapped up in the poles. We're not going to see it move down, and you get that northern storm track, which puts a lot of the Northeast into a warm sector. So you're usually getting a lot of rain, or you're getting a snow mixed to rain. You're not able to hold in that cold air. And so obviously we want a negative phase for some good snowstorms. That's when you have that weaker circulation around the Arctic. Some of that cold air can start seeping through. Oftentimes we hear the polar vortex term come in when we have a negative AO, and that storm track will start shifting a little bit farther south. So you usually will want somewhat of a either neutral or negative AO if you're going to get a nor'easter or you're going to get a good blizzard. So that storm track is a little bit farther south, and the cold is locked in, or at least available. To lock it in, we usually actually talk more about the NAO. It's the North Atlantic Oscillation, and it's the 2 pressure centers of the Icelandic low and the Azores high, and seeing the pressure difference between them to indicate the strength of blocking or not blocking. It is directly correlated to the AO, so you'll never see one positive and one negative. They kind of are in the same ballpark because one is providing you the cold, and the other one will say, oh, are we going to block it in, or is it going to go away? And they'll usually coincide together pretty well. So you want for snow, you want a negative NAO, but the positive one means that we have the stronger high and low, a high pressure gradient. So the cold air is going to stay farther north. It's an active pattern, but it's less likely that it will remain cold unless you're already in the trenches of the cold as it is. So then, of course, we want the negative NAO, where you have the weaker pressure gradient. So the cold air can move south a little bit. And then you have your blocking, which is usually what we associate with an NAO, where that cold air is really entrenched in the Northeast, and it's not going to be moved out very easily. That's usually when you have a high to the northwest, a high pressure sitting in Quebec. It's a really good place for it to block in that cold, or especially Eastern Quebec. So that'll bring you a better chance of seeing some wintry weather. We're also looking at the PNA. The positive phase is usually a more active storm pattern for us. That means we're starting to see the ridge in the west and the trough in the east. And that's, of course, allowing cold air to come in. It's a better storm track for the east, and you'll usually be a little bit colder in the east. Something that we're seeing in our short term right now is that the PNA should be becoming more positive as we get into early November. So that's been something we've been looking at for early season cold. And the negative phase is the opposite. So you would expect a little bit warmer in the east. We're on the ridge, and the west will be getting a little bit more of the action. And obviously this is cyclical, so it moves in and out most of the season. So everyone's getting their chance, really, for the most part, to get a little bit of some of that cold air. Then we finally have the EPO. When you're at a positive EPO, you're usually going to be getting a little bit more of that fast track, not allowing a lot of that cold to get in. And then once we finally switch this around and get that negative EPO, you get that Alaskan ridge, which means you can trough down the cold into the east and the Midwest. And that's usually when we'll start to see some more action. So we like a negative EPO, a positive PNA, a negative NAO, and a negative AO, if you can keep track of all that. But these are all things that when I'm trying to give forecasts for ski clients as to what they might be seeing in the next 2 weeks, because they need to figure out staffing, or they have to go and have snowmaking windows. These are the types of things I'm going to be looking at. So right now I have about a little less than half my clients on, and they're saying, all right, what's the beginning of November going to look like? And they know the variability. They're not thinking I have a special crystal ball, but they're going to ask nonetheless. So of course, snowmaking science is a little bit more than, oh, it has to be under 32 degrees. you're working with wet bulb temperature. And so it's that relationship between temperature and humidity that makes our snow guns work. You get the air and the water in there, and then you're blasting it into these temperatures. So the greater the difference between your dry bulb temperature, which is your air temperature, and your wet bulb, which is taking into account the humidity, the greater the difference, the lower the wet bulb. So that's going to be something that the ski areas will always look for. How low is the wet bulb? So the wet bulb temperature accounts for evaporative cooling. I can remember, I think it was 8th grade science, using a sling psychrometer. And this thing you like just threw around in the air as a 8th grade science kid. And I'm sure many of you can relate to that, where one of the mercury thermometers that we still used at the time had a piece of dry cloth on it, and it had one had a piece of wet cloth on it. And you would swing it around, you'd be able to see the wet bulb and the dry bulb temperature. So it's not only the air temperature that we pay attention to, but it's the humidity and then the resulting wet bulb temperature. So all snow guns and really all ski area mountain operations care about is a wet bulb temperature. Because you need to take into account that humidity. So it is going to make a really large difference depending on what humidity you have. So let's take 31 degrees and 70% humidity, and your wet bulb's about 28. That's the marginal level to get the guns on. And it's not great quality snow. So typically, you'll see the resorts turn on the guns if it's 28 wet bulb, if that wet bulb is going to come down, but they won't consistently run it at that level because that's the max. If you have a 31 degree temperature and it's 35% humidity, your wet bulb's 24, which actually produces a fairly high quality snow from a snow gun. So that is something that they're really tracking, and that I heavily focus on in a lot of my work with the ski areas. So you really want to be in the low 20s or teens, and that's when the guns work perfectly and you get the most bang for your buck. But don't always get those, and those low temperatures are becoming less common, the latest research. So we are starting to see guns being made to be more efficient with temperatures in the 20s, mid 20s, and not so much low 20s and teens, as they are less common for a lot of the areas. So this is a copy of the dashboard that I provide ski areas. We're using Sunday River, which is my home mountain. I live about a half hour away from Sunday River. And the key features that they need to know are hourly temperatures and humidity. Of course, the wet bulb is calculated for them automatically with the actual formula that was provided by some National Weather Service. Actually provides that formula online for us. So we were easily able to get that formula in our program. And then we forecast wind, and we have a 48-hour block of time where they're really trying to figure out any snow, any rain, any ice, any hazards that they're going to want to worry about. And then we get into the extended, and they have a little discussion. So this particular product formulated from an Excel spreadsheet from when I took the business over from Tony. He sent out an Excel spreadsheet to them all the way up to 2017, 2018 season. And when I decided to take over, I received some helpful advice from a few ski area operators, and they said, I think it's time you make this digital and get it a little bit more in the technological age. So that's when I partnered with two developers out of Farmington, Maine, and we actually created an online dashboard. It's the only one that I know of that exists for ski area operators to use. It's completely mobile friendly, tablet friendly. You can get alerts when different weather features are occurring. It connects to their weather stations. It has an accuracy checker. It's a really phenomenal product that I've created over the past few years for these ski area operators. So this is just a quick snapshot of it, but it's become a lot more involved. We have graphs and visuals on it now, and so they can really track how that wet bulb is moving. And it's really exciting to see how much they utilize it and how much it's necessary, especially as snowmaking becomes more dominant with less reliable continual snowfall. So the things that they care about most, inversions, happens a lot, especially mountain environments, and especially for mountains that are lower elevation. So Sunday River base elevation of their lowest lift is about 900 feet, but I have a few that are at 600 feet or 300 feet, and some are near lakes. And so you can get some really deep inversions. The other piece is icing or freezing rain, of course, for the lifts. The lifts need to be able to run safely, and icing can cause a lot of issues with the lifts running, and rapid temperature movements, because as they're snowmaking and the sun comes up, you'll get really quick spikes in temperatures. And that's something that they have to know of ahead of time. And so they're alerted to that, and then they can start shutting down the system if they need to, because a lot of resorts do not have fully automated systems yet. So the forecasts come out for 3 different parts of the mountain, for the base, the mid, the top. And so you can really find where those inversions happen or don't happen, or where we're starting to see wind shifts, high wind days. So they get all this information right from this dashboard that has been created for them. As far as how I forecast and get my data, I'm connected to the mountain's weather stations. So I actually get the real-time info of what's happening in each of those microclimates, which can be really intriguing and really frustrating. I have several mountains that are, as the crow flies, between 5 or 15 miles of each other, and the discrepancies can be amazing. Inversions can be really strong. They can go for 20, 25 degree differences from base to summit. And the only way I would be able to 100% know that is to have direct connection to their weather station. So that was a huge factor in the snowmaking forecasting for those mountains. Occasionally, the weather station information from airports is helpful, but for the most part, I look at the mountains. And obviously the Mount Washington Observatory is a huge asset to this region. I also work with Wildcat, which is right across the way from the observatory. So it's a good second batch of information. And I've worked with Whiteface as well, which has the tallest lift serve access in the east. And so Mount Washington is kind of helpful to see how that air is moving at that level, because it's over 5,000 feet at Whiteface. So that's something that's super helpful for current observations. And of course, the tried and true EWAL from Penn State, tabular outputs from different websites that break down 850 millibar winds to 925. The 925 level is really helpful in ski area forecasting, because it's a level that everyone has. For like Killington, it's their base level essentially. For Sunday River, for some of their peaks, it's the summit level. So it's a really important level that I use a lot in my forecasting. And I do subscribe to Weather Bell. They have some really great visuals, and they can get into the detail of what I need to see for these different mountains. But again, it's computer model data. The only thing that really helps in figuring out these 19 different ski areas that I work for is the experience and knowing what happens, because I've seen it happen. Knowing that a southeast wind in Maine is not going to do the same thing in Vermont. That really got me my first year. I'm used to Maine, I'm used to New Hampshire. Southeast wind, it's off the water, it's moist, it's warm. Southeast wind in Vermont does not do that. So just really learning by experience has been the most definitive factor of increasing my forecast accuracy. And so we end up at the World Cup. So my first year at the World Cup, it was 2016. As I mentioned, it was the first World Cup in the East, the Eastern US in 40 years. Prior to that, it was in the 70s at Waterville Valley. So you have the Superstar Trail, which you see here in the picture, which is already and decked out for these world-class athletes that are, they're on their third, I think, World Cup. I think Killington's the third stop. And this was the first year that they were coming to Killington. So it was a lot of logistics, a lot of fun. And I said, well, how bad could the weather be? Famous last words. So we're going to go through kind of each of the years, and each year that gave me a ball of fun. And this was the year I was really just testing the waters. I was still in broadcasting. Tony had sent me here because he couldn't do it with all his other mountain clients. So we get there on November 25th. It's always Thanksgiving weekend. So it's crunch time for the East. We hadn't had a ton of time to be making snow, but there's enough. And they'll put every gun on Superstar to get that ready. So it's really a sight when the guns are going. So the 25th was a practice day for athletes. It was about 40 degrees. It was drizzling, low clouds, and there were a lot of concerns about ceilings for the next day for racers. What would the visibility be? What would the temperatures be? Would there be any icing? Would they get ice on their goggles? And these are questions coming from a broadcaster point of view. I thought, wow, this is really specific because I'm used to forecasting for half a state. Now they want me to get into the cloud and tell me if it's icing in the cloud. Okay, so it was just a really big adaptation that I had to make, and a reality check of what's really important. So this is race day, the race day 1. And we have very weak areas of high and low pressure nearby. There's nothing really dominating the forecast. Temperatures are really marginal. They're right around 32 degrees, which made the icing concern a pretty viable concern. And there hadn't been snowmaking for a couple of days. We were way too warm. So the course condition was getting a little bit sloshy, a little bit grainy. And of course, they were concerned about the possibility of low ceilings and low visibility for the racers. So we had a predominantly southerly wind component, as we can see here. I was bummed when Unisys closed down their website, because this was really great for breaking these particular situations down. Predominantly southern component, so we're getting in some of that warm, moist air, but we still have the cool air just kind of trapped into the valley there at Killington. Temperatures were right around freezing. There was low ceilings and low visibility, to the point they actually had to delay the second run, because you need to have 3 gates. The athletes have to be able to see 3 gates in front of them to safely go down the course. And we were down to a gate and a half, basically. So they had to delay the second run of that day due to the visibility. And the whole time I'm situated in the jury trailer. And so it's legitimately just a trailer where the jury of the race actually come and talk to me on walkie-talkie or in person. These are the people who are setting the course, who are inspecting the safety of the course, who are, anything to do with this race. That's what the jury is. So I'm sitting there talking to them this whole time, kind of in over my head a little bit for year 1, but obviously a great experience, and not a lot of cooperative weather. So by the evening hours, we have our change in wind. A little weak front comes through, and we know the temperatures are going to drop below freezing overnight. And the jury tells me they want to water down the course to ice it up. But it depends how quickly the temperatures are coming down, how much wind will kick up to dry things out on the course, and what direction that wind is coming from, and will clear out. So we're talking really specific needs and wants of the jury to make sure that this course can get, they like it icy. They want it to be fast. So they want to water down the snow, basically, have it firm up, and then set the course tomorrow. So I had to give them hour by hour temperature, hour by hour cloud cover, hour by hour wind. When would the wind pick up? How strong would it pick up? And then they would determine how much water to lay down on the course. So then the next day, so now we're on Sunday, day 2 of racing. The temperatures did end up in the low 20s. My forecast verified very well, but they watered it too much. So they didn't adjust the water enough to what would have been ideal to get the race off on time. So they did delay the race about an hour to let the wind dry things out a little bit more, and have this course solidified, because it was a little bit slushy in spots. So this was the first time. It was a lot. I was exhausted, but it really solidified to me that I think this is really what I want to do. So fast forward a year, at this point, I'm officially taking over for Tony. I'm officially taking over his business. I am officially leaving broadcasting. My resignation was in, and we go for World Cup 2017. And I think it can't possibly be as much of a mess as the first year. Famous last words. So we arrive, and it's a fairly warm day. We were now ahead of a front, which we can see here on the surface analysis. This is Saturday at 18Z, so it's day 1 of racing, and there's an incoming cold front. Ahead of the front, it's gorgeous. It's 50, it's sunny. It's just a stunner of a day, but very soft course. So it was not an ideal racing day. It was a very ideal spectating day. So we were watching this cold front come in, and it comes in right in the middle of the second race. So I'm standing there with the walkie-talkie, talking to them, saying, it's coming now. The front's coming through now. They're getting showers. And they have the last 10 skiers to come down in the second race, which are your top 10, because you're in the second race, you race from 30th place to first. So you have your top 10 skiers coming down, cold fronts coming through, wind gusts, showers. And I mean, you can easily see as we're going through this afternoon where I highlighted here, the wind picking up and definitely seeing that decrease in temperature. So this was another piece where I was really in tune with the jury. We were on the walkie-talkie, the front's coming through now. They were having issues up top. Remember, these are surface observations. So we had gusts to 24 miles per hour at the base. Think of the top of Superstar, which was 3,600 feet. The wind was definitely becoming a problem. So what they did at that point is they lessened the time in between skiers so they would get them down faster and get everyone off the course. So of course it's a cold front. So what's going to happen after 50 degrees and sunshine on a snow pack, and then it drops. It was a pretty strong front that came through. Temperatures dropped to the 20s overnight, and then we had post-frontal snow squalls all throughout the day on Sunday. So it was pretty cold. It was pretty windy. They did have to adjust the race height. Well, no, second day was slalom, so they didn't have to adjust it. But it was it was definitely a windy, concerning day. And then the squalls were causing low visibility for the racers, the concern of the icing on the goggles. So again, it was another year of a lot of components on such a microclimate scale to get these racers safely down the mountain and dealing with these variable conditions. So on day one, they had a race course sitting in the sunshine at 50 degrees. And on day two, it was snowing and 22 and windy. So, I mean, it was just such a difference in weather variables. So we'll go into the next, here's the little bit of the snow shower activity. So visibility issues, ceiling issues, wind issues. We see the snow showers here on the radar. Rutland Airport reporting a lot of that snow, gusts to 20 something miles per hour, especially in the morning and with some of those squalls. So it was entertaining, another year. And so I thought, oh, it can't possibly be bad 3 years in a row. I guess I should really stop saying that. So Killington World Cup 2018, so it's the third year. So I definitely have my bearings. It's my first year there that I'm now in my business. I'm now doing this full time. I'm glad I had the first 2 years to really get honed in on this particular type of forecasting. If you remember Thanksgiving Day 2018, it was frigid. I'm pretty sure it was 3 or 4 degrees in Maine that day. So they're coming off really awesome snowmaking conditions, so they could fine tune everything for World Cup. It was a good early start to the winter 2018. It was probably the best first winter I could have had with ski areas that I could have asked for. I remember our lawn got covered on Veterans Day, and we didn't see the lawn again until the end of April here at my house in Norway, Maine. So it was a good winter. Nonetheless, there was something to spice it up when we got to World Cup. So we were coming off a really cold Thanksgiving. We had a little bit of warming coming the day before race day, and then we were back to the 30s on race day, and the Superstar base was in sunshine. So now we're marginally warm, but the ground is inherently cold from that cold snap we had. So the course did end up being quite a bit icy to start, especially up top. Summit temperatures only got to about 32 degrees. And I'd say the top of Superstar is somewhere between that top and mid level there. So 32, 33 the whole time. There was sunshine, but underneath it's inherently cold. So it was a little bit of a dicey, kind of a soft top layer of snow and then a really cold bottom layer of snow, because there's feet of snow at that point on the Superstar Trail. So we did have those temperatures then with a warm front coming through rise during the overnight. So the concerns for day 2 of racing became a freezing rain throughout the morning, and the course was so icy that they stopped almost all traffic going up. There's like VIP tours that they offer to folks who want to pay the money to go up on the course and see the sights a little closer. So that warm front came through and just made everything a mess. They ran the lift throughout the overnight to avoid the icing. The course itself was what they considered very icy, slightly dangerous. So what they do is they kind of scrape up the course a little bit because of how much was freezing. Temperatures were only about 32, 33, but you're in the overnight, you're under the clouds, and you're on a mass of snow. So it's going to remain inherently cold and inherently icy. We had that warm front come through. There's some of that precipitation. This is 8 a.m. as the it's central time, so I guess 9 a.m. for us, as this precipitation is going through right when we're getting ready for races. Races usually start 9:30, 10. So it was definitely an inclement day for racers. The icing concern was there on the goggles, the visibility concern was there, and the course itself was concerning to be possibly a little bit on the too icy side, to the point that they were scraping down the course a little bit during the event as a whole. So that was the fun of 2018. So we had the first year, which was low ceilings and drizzle, followed by a crash in temperatures and becoming windy. The 2017 was a nice day to start, but cold front comes through right in the middle of racing, and then we have squalls the next day. And then we had 2018, where we had the warm front come through in the overnight, causing freezing rain and extremely icy conditions on day 2. And then we get into 2019, and I didn't say it again and say it can't possibly be as bad. And we actually had a beautiful first day of racing. So this was 2019. It was a little bit later in the year because of how Thanksgiving landed that year. And so it gave the resort almost another week to get some snow on the ground, but the early season was good. We were under the influence of a nice Canadian high pressure. It was sunny. Temperatures were in the 20s, a little cool, but under the sun, it was still really nice. So getting into Friday, it was a good day. Saturday, we still have that high pressure really taking over overhead. The cold had settled in. Temperatures were only at the mid-teens, but we were pretty windy as well. So the wind was a big concern. Day 1 is always the GS, or the giant slalom. So it's a longer race, and they had to actually move down the start of the race because it was too windy up top. So that was something that we were dealing with in that race, but it was sunny. So I think everyone was still kind of happy in that sense, but we had gusts about 45 and 50 miles per hour at the summit. But, you can't not see the elephant in the room here with a very large low pressure system to the west. It was something we were monitoring closely and knew it would be impactful, possibly to the end of day on Sunday. So as we got to Sunday, we're watching this storm system come in. They moved up race times because they were getting concerned about getting people out of Killington and onto their next World Cup site, which is only a week later in Lake Louise. So they were shifting everything a little bit earlier. It was still a quiet, but cloudy day. There was really nothing wrong with the weather that day, but we were just trying to watch this incoming storm system. Temperatures were in the teens. We knew whatever came would be snow. They expedited the second race, not only moving it up in time, but they were lowering the amount of time in between racers. Usually it's 1.5 to 2 minutes, and they were doing about 45 seconds to a minute, just to get people down the hill, unless there was an injury, of course. So they were really lowering that time to get people moving, get people off the hill so that we could all basically get out of there. So many had issues getting to their flights. I'll never forget, you can't really drive very easily there because there's just so many people. So you can walk from the base of Superstar essentially back to the Grand Summit Hotel. And so we're walking down, and it's thankfully all downhill, walking down the road, and you just see the clouds marching down the mountain. And I'm thinking, oh my gosh, we have to get out of here because we could outrun it. We were driving back east. And I knew what was coming. So I'm back in the room and I'm throwing everything back together, getting out of the hotel. And you just see the cloud lowering. And right as we were pulling out, the first few flurries were coming down. And we just got out of there as fast as we could, because we knew we would probably get stuck if it was about 2 to 3 hours later. It's not easy to drive from Vermont to Maine. It's one of those you can't get here from there, where you're up a mountain, down, up, down, up, down. So we knew that if we didn't get out early enough, that we would be stuck. And we got to St. Johnsbury, Vermont, and we were crossing into New Hampshire. And I got an email from the mountain ops director in Killington, and he said there's 5 inches of snow on the ground and the roads are basically closed. So it was a mess getting out. But that it just goes to show you how many different aspects of the weather can impact the race. And that's what makes it really exciting. And I'm so happy it's back this year. Obviously it didn't happen last year, but it's back this year. And we'll see what this year brings. I know that was a deep data dive into what is into these ski forecasts and how even the most microclimate and the most fine-tuned details can really make such a big difference for an event like the World Cup. And it's really a lot of fun to be a part of it. These are just a few of the mountains that I work with or have worked with in the past. Like I said, most of them are in the Northeast, but I am starting to trek a little bit out west as we get farther in time. Right now I have 19 clients for this particular season. I have 8 on already, and a few do end up coming on late. So it's possible I end up getting to 20 or 21 clients, but it's all done myself. So I can't do too much more. And it's twice a day forecasting. So I wake up and I do a morning forecast, and then I'll do an evening forecast, and I do it for 7 months straight. So while broadcasting was hard and waking up at 1:30 in the morning, but I still had weekends. I have no weekends. I have no time off for 7 months, but I wake up at 4:35. So it's a little bit better than 1:30 in the morning. But basically from October 15th to at least April 15th, it is nonstop, twice a day forecasting every single day, all the way through the ski season. But I do get to ski a lot, which is a lot of fun. So that's the whole kit and caboodle here with skiing and the forecasting that goes along with it. And of course, how it relates to such an event like the World Cup. So I will now open the floor up to questions. We have one question here. Question is, do you ever interact directly with the skiers in the World Cup, and can you share how you got involved in it? So I did go over this early on, but I'll touch on it quickly. The gentleman that I got the ski area from, that I got the business from when he retired, he was working with Killington already. And I started interning under him at 2014, around 2014. And the first World Cup happened 2016. And he didn't really have backup, and he was older. So for him to take his laptop and do things elsewhere was not something he was comfortable with, and I don't think he really wanted to do it. So he said to them that he had this sort of intern, which was me, and that he could send to Killington, and that he felt confident in doing so. So that's how I got involved specifically with the World Cup, and how I really got involved in mountain forecasting. I don't interact directly with skiers, but I do join the team captain meeting. So it's the captain of every country that is there with skiers at the World Cup. And I brief them on the weather expected for the following day. So there's usually a team captain meeting Friday night and Saturday night, and they have the ability to ask me questions. I provide the forecast for them. Something we had to figure out was getting the forecast in Fahrenheit and Celsius, because most of them don't use the imperial system. So we figured that out. That was pretty easy in the digital dashboard. It was just something else that we created. So it is really interesting to interact with the ski coaches. Everyone's very stoic. They don't show a lot of emotion unless the weather is going to be really bad, and then they're really unhappy. But it's a great group of people to work with. The jury, they're awesome. They're from all different countries and all different walks of life, and it's a really fun, humbling experience. Do I also forecast snow surface conditions? I usually don't specifically. Obviously powder's easy, but it's going to be the ski patrollers that usually go around and then will determine what the snow surfaces are, mostly because obviously wind can do a number. You can get a lot of wind-blown snow. In the spring, you're going to get the corn snow and a little bit more granular, or if you have a freeze thaw. So I try and leave that more to the mountain operations folks for their own determination. And that's more of a variable that skiers and riders care about rather than mountain ops. And so when I give my forecasts, they're all internal. They're all for operations. They're all for, internal use for the most part. Then they will have their snow reporter or their mountain ops person make the determination of the snow surface. So my forecast is more for, are they going to make snow? When should they groom? Should they groom? And so on. And I don't usually forecast the snow surface, but I have been asked questions about it prior on the side privately, not from clients. And it's kind of interesting now that you bring it up that they don't ask me that, but I'm assuming that they just they make their own determination, or ski patrol make their own determination. All right, one more question. Is there any plan to make the dashboards public on the mountain's website? Would be fun to see as a skier going up. Right now, I'm keeping it internal. Some mountains do have me fill out a template that is for guest consumption that guests can view. Usually it's something printed out at the resort. It is something that I think resorts have touched upon, like how much of the information should they share with the public, but you inevitably get some people who are a little bit more critical and say, oh, well, I see your wet bulb is 26. Why aren't you making snow? So there's this balance of how much to provide the public for their own use and their own interest, like you're mentioning, versus are you going to get criticized for how you groomed, or if you didn't make snow, or if you tried to make snow and it was a waste. It just opens them up sometimes to criticism and comments that sometimes aren't fruitful. So I think that the resorts that try and make a guest template, there has been some good feedback on it, but having them be completely open to the public, I think Mountain Ops likes to keep that more controlled. What additional data point would you wish for to dramatically decrease? What additional data point would you wish for to dramatically decrease uncertainty? I don't know if I'm understanding the question. What additional data point? Oh, to decrease it. It's a good question. What would basically help me feel more confident in my forecasts? That is a good question. It's hard because, model depictions are still, while they're getting high resolution, it's still low for a mountainside, unless you're doing a lot of model work by yourself and you're running, can't think of the word, but, or experimental models. So I would wish for better accuracy or movement, how to better see the movement of the air in each particular mountain. A lot of them are in bowls, so you can have a predominantly, let's say, westerly wind flow, but once it hits this bowl, it does its own thing. And that's why that's why they hire weather consultants and private meteorologists, because the weather just doesn't do what you expect it to do by any stretch of the imagination. And so if I could somehow have a more defined wind profile, I think that would be incredibly helpful. Like if we could launch weather balloons at every resort all the time, I think it would be really helpful. There might not be so much use for me anymore, but it would be really helpful to see how each individual mountain's terrain varies or it affects the wind with height. So I think that would be a really awesome tool. Temperature I can visualize a little bit better, but wind gets a lot harder. And the other issue is that weather station anemometers are not great, especially in mountain environments. They get rimed up, they eventually break. So it's actually really rare for me to have good wind data at mid and summit points. So I'd say better quality wind data. Are using analogs from the past for nowcasting. I do. I read along with others who do analogging. There's a lot of it on Weather Bell. There's a lot of it on a lot of the weather subscription sites. It's if I hate to say if I had more time, it would be something I would do, but it's time consuming. I wish I could have a partner to delve into that more, but I'll look into what a lot of the discussions that are coming from, whether it's NOAA or whether it's other private meteorologists, or just having discussions with other meteorologists about, oh, this year's like that year, or doing that analogging more verbally rather than by hand or by myself. In the summer, that's when I do a lot of my data analysis, but it's not the time of year that I really care about. So it's hard in summer to then start getting a lot of those clues into winter, and you can just so easily get in the weeds really, really quickly. So I try and leave some of the longer term forecasting analysis to those a little bit more well-versed in it. For the most part. I mean, we all get stuck in the weeds eventually, but I try and focus as best I can. These are really good questions.
We actually had one more come in through the chat, if you don't mind.
Oh, sure.
Richard is asking, he's expressing surprise. He would have expected a bigger interest in seasonal forecasts by the ski industry as a whole. So he's wondering if you look at seasonal forecasts made by NOAA and others, and if they're at all useful to you.
They do have a very big interest in seasonal forecasts, but I think they understand the variability and the level of accuracy associated with long range forecasts. They're not going to change their plans in July or August based on what a long range seasonal outlook is saying. Even I got the email today that NOAA is announcing their long range outlook, or their winter outlook. There's no, the mountain operations crews they're not going to change anything based on what that said. I mean, it's good intel, and it's good for them to understand what is possibly coming down the pike. So they're incredibly interested in it, but I think they know that they can't do anything about the weather regardless, but they're not going to change how they're staffing, or they're not going to change how they're opening or adjusting. They're still going to really fine tune themselves on the short-term forecast, because oftentimes, we get, at least in the past, 10 years, it's very rare that they said that the CPC outlooks come out and say, hey, it's going to be really cold. I can't remember one of them actually that's come out in the last 10 years. It's going to be a cold winter. But like 2018, I mean, we got cold in November, and it was the most steady state winter. It was great. But they wouldn't have done anything differently had they known that versus what had come out as what was supposed to be a warm winter. So I'd say they have a really big interest, but I don't think that that they would hire someone to look into that as much versus them just reading what NOAA says or what the CPC said, or what the outlooks are expected to be. We always have a conference in September at Sunday River. It's called the New England Ski Summit, and without fail, everyone will say, "What's the winter going to be like?" I mean, they will ask me just because we have the rapport. And there's little bits of insight that I can see at that point or give, or what could be a little bit different. I definitely don't give I don't give much in the way of specifics. It's just not my expertise. I really want to let the experts in climate and long range to handle that. But there's little tidbits I can usually give them. It's really the short term that affects them. So like, when can they get the first snowmaking window? So it's, right now I do a long-term views for my clients on Fridays, and it goes out about 2 to 3 weeks, depending on, the volatility of the pattern. That's something that they just key in on at this point in the year, because they need to know, are we going to have to get our snowmakers in and ready and trained and make sure our equipment is up? And so that's the time frame that I think is most important to them. But that's a really good question. They really care, I promise. It's kind of like, well, it is what it is.
Yeah, no, thanks for walking us through that. That's absolutely fascinating to hear about all the specifics that are required and just the very fine-grained work that you do, and how you have to kind of negotiate between these large scale models and those very specific conditions on each mountain. So
yeah, it becomes it's an interesting challenge. Like this past few days, we had the first cold spell, and all the models were way too warm, way too cold in what they expected. And so some of the mountains felt like they could have gotten their guns on. But this first cold shot came in warm. So it becomes interesting because every year they adjust the algorithms a little bit in the models. And so you're starting from scratch of, well, what are the biases? So the initial early bias is that they're too cold, which stinks. But it's another piece of using, even though it's high resolution, it's still too low for a mountain, using that to forecast for a slope. And then how do you integrate the biases and integrate that large scale modeling to the small scale? So it's another piece of it.
wow, that's like fantastic perspective. We really appreciate you bringing this to the weather band. We haven't had anyone talk about this precise process of working at such a fine scale. So this is absolutely wonderful that you could join us today. We really appreciate it.
Yeah, thank you for having me.
Yeah, well, thank you all the participants for joining us for this talk. We really appreciate it. And we hope to see you over at amsweatherband.org, especially in the community. Come share your voice there. And we look forward to continuing our weather conversations. So again, thank you so much, Mallory. And thank you all. Have a great rest of your day.
Thank you.